Problem number 1. A 3-liter container holds 0.68 moles of into gas at 417 Kelvin. What is the pressure inside the container? Now, volume is equals to 3 liter and N is equals to 0.68 mole. Now, the temperature is equals to 417 and then the pressure is unknown. To find the pressure, let's use the formula PV equals nRT. The P is equals to 3 equals 0.68 mole times 0.08206 times the temperature 417 and times this 0.68 times 0.08206 times 417 is equals to 23.268 and copy the volume 3 is equals to 23.268 divided by 3 and cancel is equals to P equals 23.268 divided by 3 is equals to 7.77. Let's proceed to problem number 2. Problem number 2. At 32 degrees Celsius and 825 torr of pressure, 2.5 mole of argon gas is introduced in a container. What is the container's volume in ml? N equals to 2.5 mole and the temperature is 32 degrees Celsius. To find that to convert the degree to Kelvin, it's T key is equals to TC plus 273. The temperature is 32 degrees Celsius plus 273. Our temperature is 305 Kelvin. 305 Kelvin. And our pressure is, let's convert this to 825 torr into ATM. 825 torr divided by 1 times 1 ATM is equals to divided by 760 torr. 825 torr times 760 torr is equals to 1.09 ATM, and now our P is equals to 1.09 ATM, and we find the volume. Volume is equals to find the volume, let's use this formula P equals N RT 1.09 is equal volume is equals to 2.5 times 0.08206 times 305. multiply this 2.5 times 0.08206 times 305 is equal to 62.57, and copy this volume. 1.09 b divided by 1.09 and cancel this. B is equals to 57.40 liters. And now, to convert liters into millimeters, 57.40 liters divided by 1 equal to 1000 ml over 1 liter. Cancel liters. 57.40 times 1000 ml is equals to 57,400 ml, and that's the answer. And our volume is 57,400 ml. Problem number 3. How many grams of CO2 need to place in a 300 ml negative 52 degrees Celsius container to achieve a 75 kPa pressure? P is equals to to convert kPa into ATM. Let's solve. 75 kPa divided by 1 times 1 ATM over 101.3 kPa. Cancel. 75 times divided by 101.3 is equals to 1.35 ATM. Our pressure is 1.35 ATM. And next, our volume is equals to
produce a pressure of 95 kilopascal.
And our volume is 300 divided by 1000 is equals to 0.3
ml container at 24 degrees
liter.
pressure of
And now our temperature is equals to
we're going to convert
221 K. To
1 atm is
convert our temperature into Kelvin,
1
TK
kilo.
is equals to negative 52
Cancel.
plus 273
You divide
is equals to 221 Kelvin.
5
And next, Rn is equals to
divided by 100.
0.22
3.
mole. The solution that we use is the formula that we use is PB equals nRT. 1.35 times 0.3 is equals to N 0.08206 times 221. Next, 1.35 times 0.3 is equals to 0.405, and 0.0806 times 221 is equals to 18.1356 N. And then divided by into this 18.1356 N, and copy also 18.1356.
Our volume is 250.
Cancel. 0.405 divided by 18.1356 1356 is equals to N equals 0.022.
25.
And to know the grams of CO2, let's solve. CO2 C plus 2 times 0, 12.01 plus 2 times 16. 2 times 16 is equals 32 plus 12.07 is equals to 44.01 gram per mole. And 0.22 mole CO2 divided by 1 times 44.01 divided by 1 mole is equals to 9.68, and this is the final answer for problem number 3. And now let's proceed to problem number 4. The temperature of 1.5 moles of helium gas is 36 degrees Celsius and the pressure is 2.20 atm. What is the gas volume? Pressure. Our pressure is 2.20 atm and our temperature is 36 degrees Celsius. To convert the temperature, Tk is equals to 36 plus 273 is equals to 309, and Rn is equals to 1.5 moles. 1.5 moles. And our volume is unknown. Let's use the formula PB equals nRT. Pressure is equals to 2.20 is equals to Rn is 1.5 times 0.08206 times our temperature is 309. 1.5 times 0.08206 times 309 is equals to 38.03481, and copy the pressure 2.20 divided by 2.20 same as, and cancel. B is equals to 38.03481 divided by 2.20 is equals to 17.29, and our volume is 17.29. Problem number 5. At a certain temperature, 2.24 moles of CO2 gas at 3.15 atm take up a volume of 45.28 liters. What is this temperature in Celsius? T is equals to 3.15 atm. Volume is equals to 45.28 liters. N is equals to 2.14 mole, and the temperature is unknown, and the formula is PB equals nRT. Substitute this to make the temperature, to make this divided by this by nR, and cancel. PB equals to divided by into nR equals to T. T is equals to PB over nR. T is equals to pressure 3.15 atm AP ATM times 45.28 liters divided by 3.24 mole times 2 key times mole divided by 0.0821 liters times ATM, and let's cancel ATM liters, moles, and we have Kelvin. T is equals to 3.15 times 45.28 times 3.24 times 0.0821 is equals to 3.61 K Kelvin, and the temperature is negative 269.39 degrees Celsius. This is the final answer.